Okay, so we're going to start our next unit, which is linear and quadratic inequalities, and take a look at section 9.1, linear inequalities in two variables. So we are going to take a look at linear equalities in two variables that could look like one of the following four, where you have a less than symbol, less than and equal to, greater than symbol, greater than and equal to, where a, b, and c are real numbers. Now, just to remind you a little bit of some past math that you would know. From last year, if you have an equation in this form, it's general form. If it's in the form of y equals mx plus b, it's y-intercept form, or slope-intercept. Okay, and I don't think you covered this last year, but if you have an equation in the form of ax plus by equals c, this is called standard form. And we'll be looking at these two. Okay? Now, just to go over what an inequality, or linear equalities in two variables is. Okay, so an inequality in two variables, x and y, describes a region in the Cartesian plane. Okay, so we're talking about an area. Its solution would be the set of points that satisfies the linear inequality. Okay, we can call it a solution set or a solution region. So the line related to the linear inequality of y equals mx plus b, or boundary, divides the Cartesian plane into two solution regions. So the equality form of the inequality, okay, so if I take an inequality and write it as an equality, it's the equality part that defines the boundary, which is the line that will separate what's above the line from what's below the line. For one of the solution regions, if y is greater than mx plus b, and it's true, then you would have the region which is above the line. Okay, so this is the blue region on the graph. If the other solution region, y is less than or mx plus b, is true, then we would get what's below the line, which is the pink region on the graph. Okay, so provided that y is on the left-hand side of the inequality, if the inequality is greater than, it means above the region. If it's less than, it means, above the line, and if it's less than, it means below the line. Okay, and the solution to a linear inequality in two variables is a solution region that may or may not include the line. Okay, so if it's a dotted line like this one, then the line is not part of the solution. If it was a solid line, then the line would be part of our solution. Now we're going to take a look at two methods to graph inequalities in two variables. The first one is using the slope-intercept. Step one asks you to graph the corresponding equation. Okay, so that would mean you want to graph y is equal to mx plus b. You want to solve the inequality for y. Simply means that you want to isolate for y and consider whatever the inequality is. It will tell you whether you're going to graph above or below the line. Once you've written it in this form, then if it reads greater than, you shade the region above the line. If it reads less than, you shade the region below the line. Now remember, this is only true if y is to the left of the inequality. So y must be to the left of the inequality. Okay, so an example would be something like y is less than mx plus b, so to the left. Now, if you if the inequality is less than, equal to, or greater than and equal to, it means that you want to graph a solid line in the shaded region. Okay, it's the equal sign that tells you want to graph a solid line. If it just reads less than and equal to, or sorry, less than and greater than, it means you want to graph a dotted line in the shaded region. So because it doesn't read equal to, you're going to graph a dotted line. Our second method is to use the x and y intercepts method. Okay, and what this means is that you're going to have your equation in standard form. Oops, hang on. Standard form. Okay, you start off with the same step that you would for our method 1, but this time you are going to be looking for your x and y intercepts. Okay, once you have your line graphed, then you are going to select a test point from each region to determine which contains the solution. And then whichever one is in the solution region, you are going to plot the point there, and then you will shade in the half plane in which this point is located. Okay? Alright, in my next video I will go and go through example 1 with you.